Hello, and welcome to Learn Python 3 the Hard Way, exercise 33, where we cover a while loop. While loops are in almost every programming language, unless they explicitly don't want the while loop for some reason. You're going to have some way of doing unbounded looping. So what I mean by unbounded looping is you can make this loop forever if you want, using a while loop. It just goes until some truth condition fails. A for loop is bounded, meaning it should only go over a finite thing unless you really work hard to make it not do that. So typically you rarely have to use a while loop. In fact, if you're using a while loop, there's a chance you just don't understand how to make it a for loop. So part of this exercise is doing that. Now I have the code here and I want to demonstrate something. So it's not hard to understand a while loop. I mean, pretty much you say while, okay, that's it. You give some truth condition, sort of like a if statement. And it's basically an if statement with a jump. So the while loop runs, and when it gets to the end, it jumps back up to line 4 and does this test again. Another way to do this would be, let's imagine I could do this, okay? So I got line 4, and I'm going to go run, okay? And I'm going to say, if I is less than 6, go to 4. Okay, if I had some imaginary programming language. And then I could also do, you know what, actually, if I'm going to make this correct, I'm going to do this. If I is less than 6, then go to, and then come down here and do that. So if I had an ability to go to another line, that would be what this is, what a while loop does. So a while loop is pretty much an if statement. It does a test at the top, okay, and then a jump at the end. And it jumps there. In early programming languages, that's what they did. You didn't really have while loops. You just had ways to jump and do tests and stuff, and that's common in assembler and things like that. But now we have a while loop. And even more recently, a lot of languages are just kind of making while loops not really all that useful. Python's kind of one of those. So we have this while loop, okay, and the thing about it is it's unbounded. So a for loop that did this same sort of thing would be for I in range 0, 6, and then numbers dot append I. Now that would be guaranteed to stop after 5, okay, but a while loop is not guaranteed to stop. So while this is easy to understand, we were using for loop down there, it's easy to understand this. The bug that is always caused with while loops is you forget to do that. And let me just comment that out instead. Now, if you think about this for a second, right, it makes total sense that this would loop forever because I never changes. So if we walk through this, and let's run it actually. Okay, so you see this is running for, basically forever, right? It will sit here adding numbers to that list until finally it just runs out of memory. And if you look, I have here at the top, or at the bottom and at the top, I is 0. It's always 0, and then the only number it adds is 0. That's because I never changes. And that's sort of the flaw of the while loop. Is it's too hard to get the variation you need of the test at the top of a while loop right. So what ends up happening is, and a lot of people spend a lot of time trying to prove this, but it's difficult to prove that a while loop will end. Like it's very hard to figure out that a while loop, like complicated while loops, will actually end. If you use for loops and other similar sort of like bounded looping, like the functional programming stuff we did in 23, where it's bounded, there's an if statement, but it's mostly bounded, right? As it runs out of lines, okay? In this while loop, it doesn't run out of anything. I just keeps on going. So when you sit down to write a while loop, the first thing you should ask is if you can do it as a for loop. And the second thing you should do is write the incrementer or the test first. So I'm going to gut this real quick. Well, first, let me show you how this is supposed to run. So that's what it's supposed to do. It's just supposed to add some numbers and print them out. Okay. Now I'm going to show you how I would write this. I'm going to skip these prints for now. I'm going to rewrite this while loop, okay? So I would say while I is less than 6, okay? And before I do anything, I'm going to jump down one extra line. I'm going to do I equals I plus 1. Okay? Now I know that that is done. That should only run once. I go like that, and it doesn't run forever. That's the big test you want, okay? Then I go in and I do numbers append I. So that way I know that it's going to end and it's been correctly done. And that's how you should write your while loops. In fact, that's how I write a lot of these sort of like bounded or like functions that if they need to return, I write the return first. If it's an if statement and I need an else, I write the else first. That way I don't forget it and I make sure that that works right. Then I fill in the blanks. Okay, so once you have that, and let me bring us back to where we were. Once you have that, you know how to break a while loop. Now you can do some very interesting breaks and things like that. Where you really get into trouble is when you start putting if statements in there. So if you're doing like if I is less than 3, that would be 1, and else I equals I minus 1. Okay? Now, off the top of your head, looking at this, trying to think about how this was going to run, is this ever going to end? Okay? So I just kind of cranked out this puzzle. Do you think it's going to end? All right, well, let's go see if it will end. What will this do? Yeah, see, it's never really going to end. It's going to bounce around between 2 and 3, 2 and 3, 2 and 3, and 2 and 3. Okay, so that's an example. When you run into trouble with while loops, it's mostly because you're doing something to the incrementer, and usually that's involving some very complicated logic to figure out how it should increment. Your better bet is to find a way to use a for loop, or to sort of just prove that the if statements you're using are actually going to end first, and then write what the while loop does. Okay, so that's one example of breaking it. You could come up with all kinds of crazy harebrained ways to break this. Let me see, what's another one? Oh, actually, no, what we should do is, how would you debug this? Well, obviously I'm printing it out, and I know it's 3, 2, 3, 2, 3, 2. So it's already kind of doing it in this exercise. But probably what I would do, see how it's like that, F at the bottom? I would add in print I is less than 3. Okay. And then I would say print I is not less than 3 would probably be the best way to say that. Okay. And then I would see, okay, and I'd scroll back through, and I'd be able to see that the numbers stay there, and I would say I is not, and I is less than 3, and then I is not, and then I is less than 3. And I would see that it's bouncing around between those two statements. And then once I did that, I could probably figure out how to change these incrementers, so that they would work correctly. Okay, that's pretty much the while loop. The while loop is not a difficult concept. It's, it's basically, like I said, it's an if and then a jump. But it's difficult to use, so that's why they're kind of just, it's not really common to see them. Now, one place you do see them, okay, something the for loop just cannot do, is when you want to do while true. And let's do this. You know what? And equals. Let's do this. Okay. When you need to loop forever, there's all kinds of systems that have to loop forever. You don't want them to stop. So this is just going to print out a whole bunch of capital O's. Okay. The while true is kind of your only option. And you'll run into this when you make servers, video games that have to run forever, anything that has like an event loop or has to do something all the time. You do a while true. But that's sort of like the one time you use a while loop. On purpose. Okay, that's the end of exercise 33. I will see you at the next one.